Real-time process optimization is about delivering live prescriptions in order to adjust settings in real time to reach objectives under changing conditions. No process ever runs under perfectly stable conditions. Raw materials change, equipment slowly drifts, operators rotate, and external conditions constantly evolve. Because of this variability, most plants operate conservatively. They rely on fixed operating standards and recipes that are safe and repeatable. But those standards were defined under past conditions and are composed of operating windows within which hidden performance potential often remains. And when conditions change, those standards are no longer optimal. So the process stays stable, but performance potential remains untapped. That gap between stable operation and true optimal performance is what Braincube helps close. Variability is not the exception in manufacturing. It is the normal state of operations. Braincube connects the data coming from the plant and allows teams to continuously track how the process is actually performing. You can monitor key performance indicators such as throughput, quality, energy consumption, or material losses. But more importantly, you can observe the entire process in context. Instead of looking at isolated signals or dashboards, the system captures how variables interact across the production process. This gives operations teams a clear view of how the plant behaves in reality, not just how it was designed to run. Braincube uses its learning algorithm to analyze historical and live production data. Instead of building theoretical models, the system identifies situations from the past where the plant operated under conditions similar to the current ones. From those situations, it reveals which variables had the strongest impact on the outcome. This allows the system to identify the real drivers of performance, the variables that truly influence throughput, quality, energy, or yield. Often, the surprising discovery is that only a handful of variables truly drive the outcome. Once these drivers are identified, the system organizes them into two categories. First, conditions. These are variables that influence the process but cannot be controlled directly. For example, raw material variability, environmental conditions, or upstream disturbances. Second, settings. These are the levers operators can actually adjust: temperatures, speeds, flows, pressures, and so on. This separation is critical. Operators cannot change the conditions of the plant, but they can adapt the settings to respond to those conditions. Instead of relying on fixed operating standards, Braincube continuously calculates the best settings for the current conditions of the plant. The system evaluates what is happening right now, compares it to similar situations from the plant's operational history, and determines the settings that produced the best results in those situations. It then delivers a clear instruction, not a report. Not an analysis, a simple operational recommendation. What should the process run right now, under these conditions, to reach the best achievable performance? You can think of it like a navigation system for industrial operations. Just like a navigation system continuously recalculates the best route depending on traffic, Braincube continuously recalculates the best operating targets depending on the current conditions of the plant. This is how operations move from fixed standards to dynamic performance steering. Real-time process optimization is the Braincube new product that transforms how to steer the process. It is about delivering to your operators live prescriptions in order to adjust settings in real time to reach objectives under changing conditions.